So today we are talking about porting Linux applications to NuttX because there is a huge benefit of developing for an embedded system and then being able to reuse the application on another system based on a different operating system or a different SOC. My name is Alin Jerpelea. I've been together with the NuttX community for around 7 years. And I'm based in Sweden, and I work for Sony. I will start with an introduction to Linux, because this is our donor, I would say. So the Linux has been created in 1991 by Linus Torvalds. In 95, the Linux kernel has been ported to different architectures. 95, we also have the creator of BusyBox, creating BusyBox. In 97, we have the Linux router project, a Linux as small as a single floppy disk. 1998, we have UC Linux, project start. 99, the ARM architecture has been added to the Linux kernel. 2002, we get micro C Linux patches to mainline. And in 2005, we get the preempt RT in the kernel. The full history can be found on the link at the bottom of the page. Linux is flexible, modular. It costs almost nothing. It is open source. It is standard compliant, and it is easy adaptable for many purposes. As you can see in the pictures, you can find Linux from the IBM Watch, in the smartphones. The Linux kernel runs on our Android devices. It is also in the rockets, and you also have it in your home, in your routers. The main advantages of Linux are support for powerful ARM and RISC-V system on the chips. Low boot time on the right machine. Not really low. It's a few seconds, but it's still fast. Virtualization, which increases security, and the ability to host virtual machines, which also increases security. But there are drawbacks. The code size, there are many megabytes. The footprint, many megabytes too. The boot time, if it's not optimized, tens of seconds or even minutes. It is not really real time, even though we have preempt RT, which helps. It is not really low power, not from a microcontroller perspective. And it doesn't fit on a small microcontroller due to its bigger size. And now we can talk about NuttX, which may save the day, or may not. We will see. NuttX is a free and open source real-time operating system with an emphasis on technical standard compliance, and it has a really small footprint. It is scalable from 8-bit to 64-bit microcontroller, and the main governing standards in NuttX are POSIX and ANSI, the same that can be found in Linux. Its main characteristics are modular, fully preemptible, scalable, highly configurable. It is easy to be extended to new processor architectures. It is real-time, deterministic, has support for on-demand paging and priority inheritance. It has flexible memory modes, flat, protected, and kernel mode. Main advantages: its strict POSIX compatibility, its scalability, and the fact that it provides drivers and many features for an embedded project development. It supports the major file systems. It supports the main file systems as listed in the picture, and many more will be added on our journey. It supports also network protocols and many resources. You can use IPv6 or IPv4. You can use network address translation. You can use routing. It supports sockets and also TCP and UDP. It has graphic support for frame buffer, similar to the Linux frame buffer. It supports LCD and OLED screens. It supports a minimalist X11-like graphic server called NuttX server. And it has many libraries for drawing on the NuttX server. Also, it supports widgets. We have support for external LVGL graphic library. And it supports the VNC server, which is very important for different applications. It has USB host support with the major modes, including keyboard, joystick, and mouse. And it also supports mass storage. All the functions that you find in Linux. It also has the ADB, similar to the Android debug bridge. It has composite device, which is also needed for newer implementations. It supports audio with several codecs and more are added. It has an audio player for local and network streams called NX Player. And it supports many peripherals connected over SPI, I2C, I2S, one wire. It has support for ADC and DAC, PWM, SDIO, SD card, MMC, encoder, RFID, NFC, and many sensors and devices. You can check the config and see if what you need is already there, or you can simply port it if the license is compatible. Among other features, we have support for power management with support for low power. We have T-class kernel mode, dynamic binary loader, pseudo terminal, kernel modules, similar to the Linux kernels, syslog, SMP, IO redirect, and modem. We have support for several modems directly in NuttX. Normally, NuttX can work without bootloader, the kernel itself being responsible for initializing the microcontroller's clock, memory, and everything else. It can work with MCU bootloader, which can be used if the over-the-air firmware update is desired. And it can also work as FOTA without a bootloader, where a second instance of NuttX is used to flash the main instance. It has been used until now in real-time robot operating systems, RTOS, in together with the MicroROS project, in an open source computing platform for robot control and PX4 autopilot. It has been used in health, IoT devices, and Sony used it in audio products in the past. Many companies are also using NuttX. Sony uses currently NuttX in the Presence platform. Google Project Ara was using NuttX as a backbone for Project Ara. Wilderness Labs created Mido. Xiaomi is using NuttX for the Vela platform, and they are very active in the NuttX community. Thanks for all the Xiaomi developers, that work together with us to make NuttX a better real-time operating system. Espressif Systems and NXP, which is widely supported in NuttX. Today, I will talk about the Sony's Presence board. We are later organizing a small workshop with 10 boards that are accessible and available on site. After the workshop, the persons participating in the workshop will be able to keep the boards and enjoy playing with them. But more on that from my colleague in a few hours. As a simple exercise, I took the iPerf application from Linux, and I just added it to the NuttX and run it on this Presence board. To do this, you have to start from a basic configuration. Our way of selecting the configuration is by issuing the tools configure shell script, followed by the board, in this case, this Presence board. And the basic configuration that I used was the NuttX shell, NSH. So more information on this you can find on the wiki page on how to configure and use a basic configuration. What I did was to create a new kconfig file where I defined the iPerf3, as you can see in the picture. I edited the make defs so that it is discovered by the build system. Again, quite easy to define everything. You can do the same thing for any application that you want to port. I added the C files to the make file so that the compiler can find it. I set the code to be downloaded on runtime. As you can see, the code is downloaded directly from GitHub, and then it is compiled. After doing this, if the make menu config command is issued on the terminal, you get the iPerf3 as a new selectable option in the menu. And then you just run make and wait for the image to be generated. As you can see, the nuttx.spk file is successfully created. I checked the new code that the new code is compiled. The file is listed after my command, so the object is there. And this is how any Linux application that is POSIX compliant can be ported. Be careful when you port this, because some licenses are incompatible and some licenses are undesirable for specific products. So this is something that you as a developer will have to look into. NuttX is implemented from scratch to be POSIX compliant RTOS. Even the internal APIs and the kernel follow this approach. It has many similarities with the Linux kernel subsystem, which makes the transition to NuttX more pleasant for developers. If you develop something for the embedded Linux, you will feel at home. It has 32-bit compatibility. Nowadays, the desktop processors moved to 64-bit, and the 32-bit support is removed slowly from the Linux kernel. So that there is a huge gap that NuttX can, in my opinion, fill with support for the 16 and 32-bit compatibility. Thank you. If there are any questions, I would gladly take them now or later online.